For this lesson, we'd like to talk about electric heat. Electric heat is growing in popularity, especially in areas where there's high fuel costs. We want more individual control. Some of the advantages of electric heat is it's a very low initial cost. The electric heating devices don't need any oxygen or air supply. The highest temperatures needed are below ignition temperature most materials. Therefore, electric systems are considered safer than other materials. Due to an absence of combustion and combustion gases, there's less danger of toxic conditions. You don't have to have a chimney for electric heat either. Advantages of electric heat also include equipment normally requires less space than the equipment needed for other systems. Individual room temperature control is very easily obtained, and it's a very clean operating system. Disadvantages of electric heat: cost per unit of heat is higher than for other types of heating systems. Additional electric circuits are required, and they are high voltage circuits. The principles of electric heat is that electricity is a form of energy that can be changed into heat energy. Heating with electricity can be done directly or indirectly. Direct heat includes resistant heating accomplished by passing a fluid over an electric heating element, or radiant heating accomplished by heating an element to a temperature high enough to give off heat. We can also use thermoelectric heating. Indirect heating uses a heat pump. For commercial uses, heating operations in industrial processes are used, such as fast drying of paint, melting of metals with low melting temperatures, cooking and baking, and providing hot water. Residential uses can include being a primary source of heat, providing supplementary heat, and using electricity to power heat pump systems. Resistance heating can provide heat in parts of the house not well heated or where standard heat is unsafe. It can also be used to heat additions to buildings. The electric furnace is the first type of electric heat. Electricity can be used to provide heat for warm air or hydronic central heating systems. Furnace capacities can range from 34,000 BTUs per hour, that's 10 kilowatts, up to 120,000 BTUs per hour, or 35 kilowatts. Forced air furnaces use tubular heating elements one at a time in stages of 5 kilowatts or 10 kilowatts, sequenced by a relay panel. The thermostat is usually a low voltage type with 2 heating stages. Incoming power is 240 volts while the controller 24 volts. A hydronic boiler typically has a capacity of 34,130 BTUs per hour, that's 10 kilowatts, to 81,900 BTUs per hour, that's 24 kilowatts. The total furnace output should be about 20% over the design heat load. The extra 20% can be wired and controlled to turn on and handle excessive heating loads. In other words, you can stage it. Supplementary electric heating is used to heat additions or where expanding the existing system would be difficult. Systems used can be radiant heat panels built into the walls, baseboard heaters, or resistance heating wire embedded in the ceiling or wall plaster. This is a wall-mounted electric resistance heating. Air enters at the top. A fan forces the air down over the electrically heated elements. Air leaves the unit through the lower portion of the grill. Metals are generally used as the heating elements. They're designed to permit certain current flow and provide the required heat. Power in the metals may be either 120 volts or 24 volts alternating current. Units may be mounted in protected cabinets such as baseboards, or wires may be installed in floors and ceiling. Systems do not glow are described as non-incandescent temperature units. Some units operate at incandescent temperatures. The higher the heating element temperature, the smaller space it must occupy. Some units have high temperature heating elements and release both air, convection heating, and radiant energy. Electrical energy is changed into heating energy in the following ratios. 1 watt is equal to 3.415 BTUs per hour. 100 watts is 341.5 BTUs per hour. And 1,000 watts is 3415 BTUs per hour. Voltage multiplied by amperage flow in a circuit generates watt equals wattage. For most computations, 1 watt equals 3.4 BTUs per hour. When converting from a coal or gas-fired heating system to an electric resistance system, the building needs to be modified. Specifically, we need to reduce the heat transfer and air infiltration. The walls and ceilings should be insulated. Basement walls or floor slabs should be insulated, and windows should be double glazed. Wood or plastic window and door frames are preferred. The walls should have a 4-inch insulation. Solar heat may be used to supplement electric heat. East, south, and west exposures should be utilized for as much solar energy as possible. Electric resistance heating produces no draft. Humidity control may be required for dehumidification of the spaces. The tight house does not pull excess water vapor out and replace it with drier outside air. There's 3 types of electrical heating wires. First, you have an open wire, which is the top one. Then you have an open ribbon, and then you have a tubular encased wire. The looped wire transfers heat better than straight wires and controls resistance. Open wire is usually nickel chromium resistance wire mounted on ceramic or mica insulation. A word of warning that open wires must be carefully protected to avoid dangers of burns and electrical shock. They cannot come into contact with metal objects, humans, or animals. Ribbon-type resistance heating wires are made of the same material, mounted in the same way as open wire. The ribbon design offers more surface exposure for air contact. Ribbon systems must be carefully covered by a grill to prevent burns or shock. The heating element in a tube-encased wire type is similar to the heating elements used in electric stoves. These are nickel chromium resistance wires surrounded by magnesium oxide powder. The powder-coated wire is enclosed in a heat and corrosion-resistant steel tube. The heating element may reach very high temperatures in electric heat. Tube-covered elements are sometimes placed in a fin tube aluminum casting to increase the heating surface and reduce the danger related with high-temperature wiring. Some types of electric resistance heating elements are similar in shape to a tube-encased element, constructed as follows. Helical wound coil or resistance wires supported by ceramic insulators. Open coils made of nickel chromium wires wound on the insulators, and ceramic discs shaped like donuts with a helical coil passed through are common. Small diameter coil resistance wire inserted into metal tubes with powder as insulation. These tubes are formed into many shapes. When heated to 1550 degrees, the tubes become a dull red. Sometimes metal foil is expanded to form mesh-like resistance heating strips, which operate at a lower temperature than resistance-type wires, about 1450 degrees Fahrenheit. The baseboard electric heat is one of the most popular forms of natural convection heating. The electric resistance coil is mounted in the casing. Warm air is light and rises. Cold air is heavier and settles to lower opening and is then heated. The units are mounted on a wall close to the floor, usually under a window. A stair-step heating element provides direct airflow so that the wall is cooler. This design provides more room to the heat. It should be mounted on a wall, and if built into the wall, dust in the unit may cause streaking on the wall. Keep passages clear to prevent poor airflow and overheating. Each unit may be thermostatically operated on its own. The baseboard heating is virtually easy to install. It has no moving parts and is noiseless. The installation of a safety switch is strongly recommended, and room temperatures may vary greatly with baseboard electric heat. The variation between floor and ceiling can be 4 to 15 degrees with 2 heating periods per hour. 5 to 6 heating periods per hour are the recommended. Baseboard units are available in lengths from 36 inches to 100 inches, and the units may have one or more heating elements in parallel. It's very desirable to keep the current load to 20 amps or less per circuit. The 240 volt circuits is desirable. The next type of heating element with electric is a duct heater. It can be a primary source of space heating. It's often used as a supplementary unit for a heat pump during the coldest weather. may be used for auxiliary heating in large air conditioning installations. The electric heating elements can be placed in existing duct systems. Radiant heat can also be done with electric. Radiant heat is the infrared band of light energy waves impacting an object. The frequency of this radiation is 900 millihertz to 2500 millihertz in a wavelength of 4 microns or less. Objects absorb rays and become warmer. The heaters are usually gas-fired and electric heated elements. Electric radiant heat energy may be provided by a lamp, high-temperature electric element, ceramic element, or low-temperature electric cables. The radiant heat rays focus on an individual will keep the person comfortable even if the ambient temperature is below the comfort range. Radiant heat decreases as it travels. Radiant ceiling heating is very popular for homes. Electric heating cables are enclosed in the ceiling plaster. The ceiling cables range in output from 500 watts to 5,000 watts and are 1/8 of an inch to 1/4 inch in diameter. Ceiling cables release 2.7 watts per foot and are spaced usually on 1.5 inch centers. The temperature is about 150 degrees. It heats the ceiling surface to about 120 degrees Fahrenheit on 1.5 inch centers. Wider spacing reduces the ceiling surface temperature to about 100 degrees. Drywall uses a lower wattage per square foot, about 2.2 watts per foot, and 60% of the heat is released by radiation. Floor cables are much heavier. They're rated at 2.7 watts per foot, and 45% of the radiant heat is released. Radiant lamps and glass panel heaters are another type of electric heat. Electrically heated fixtures use coarse lamps that are either Vicar or metal sheathed. Some use an open resistance wire or ribbon. Quartz lamps usually consume 800 watts to 2500 watts. They provide 2700 BTUs per hour to 8500 BTUs per hour. The quartz lamps and wires reach about 1200 degrees Fahrenheit and they're about 60% efficient. I can increase the efficiency to 85% by using a tungsten coil. Air-filled tubes operate at 1500 degrees to 1700 degrees. If filled with an inert gas, they can operate at 4000 degrees. They emit infrared and visible rays. Radiant heat lamps may have 45-degree reflection or 90 and 60-degree reflection and radiate about 50 watts per square foot from at least 2 directions. Install 1 lamp for each 1 degree Fahrenheit desired above the lowest expected temperature. Use 2 watts per degree above the lowest coldest temperature expected. If the lamp is further than 10 foot away, apply 5% additional wattage for each foot of distance. When placed outside, use windshields. Glass panel heaters give off about 60% radiant and 40% convection heat. Electrical conductors are installed in the back of a glass and covered with a reflective surface. Element operates at about 500 degrees Fahrenheit. The glass surface is about 350 degrees Fahrenheit. Sometimes they're placed on a wall under a window. Snow melting systems are also used in some temperature zones. An output of 100 watts to 200 watts is needed for each square foot of surface to be serviced. It's usually provided by heating the gas-fired radiant heat is usually provided by heating ceramic elements in an incandescence. Reflectors are used to focus the heat, and about 50% of the heat energy is converted into radiant heat, and the units operate between 700 and 1600 degrees Fahrenheit. When you install heat coils, there's a few procedures that has to be followed. First, heating coils must be installed according to electrical codes and the manufacturer's recommendations. Electric heating installation must be carefully checked. Be certain it's fire safe and safe for human and animals as well as efficient. Baseboard heaters must have unhampered air circulation. Unit heaters must not be installed dangerously close to flammable materials or surfaces. Furnace units must be shielded electrically and heat protected. All metal parts of the furnace must be grounded. Electrical service must use wire sizes appropriate to the voltage and amperage of the circuits. The circuit must be properly fused and provided with adequate limited safety controls. Controls must be designed for the correct voltage and current. To service heating coils, it is very dangerous to use flammable fluids for cleaning electric resistance heating units. Don't do it. If they need to be cleaned, easiest way to brush them off or use some sort of air. Check terminals for tightness and cleanliness. Use a voltmeter or ohm meter to check all connections. An ohm meter is preferred as it can be used with the electric service disconnected. Things you want to check for is the thermostat, limits, control, and relay. Check the power at the fuse box and circuit breaker box. Check fuses and connections. Check the thermostat. Check limit switches. Check relay coils. Check relay points. And check electrically heating coil circuits. If the blower turns on and off, if the heater strips heat and cool as the blower runs and stops, the thermostat is short cycling. Anticipator rating may be set too high. Limit control may be opening and closing. You may have an incorrect low voltage, and the motor overload may be opening and closing. If the blower runs and there's not enough heat, look for the dirty filters. You might have voltage that's too low, and only some of the heater elements may be energizing. Look for circuit breakers, element burned out, a sequence switch not properly operating, or the second stage of a two-stage thermostat is not operating. If you have no power or low voltage, look for the sequence switch defective. Look for an open thermostat. You might have low line voltage, low transformer output, or the motor's not operating. Look for a defective capacitor or defective internal overload. If you have proper voltage at the motor, defective overload, or defective motor capacitor should all be checked.